Ade everyone, Mayank. Hey, alright. So today we will be discussing about some of the CVEs, some common vulnerability exploits that you might have found in the whole cloud at the moment. Let's see if someone else also visit this stream. Alright. So let's continue. Let's hop on to our docs, Google Docs. I will mention about our you know today's aim, and then later we will try to mention some of the summary as well. Some of the points that we will capture as in the form of the summary. Oh. All right, so let me share my screen. Dhruv Agro. All right, so now we'll try to cover. It's our fourth live. I think we should take these particular topics in the next one. Right, so we'll try to take some of the topics from these CVs, and we'll try to take those. We'll get to know about those particular different CVs from different blogs as well as docs that we might found in different projects, maybe from the Slack channels, or either from the Reddit, or either from some of the blogs that are available on the internet. It's just kind of we'll go through the whole surface web. See what are some of the previous CVs that we might have found, or some of the developers might have found, and we'll try to understand what got wrong in those particular topics, and then later we'll try to see if we might also get some CVs ourselves. It's kind of rare. We are new. I don't know as much about the CVs. I just know about the whole architecture of cloud and CloudNative, or either about the Kubernetes as well. But I doesn't know as much about the whole, different landscape. I doesn't know how to find those CVs as much. I'm a user. I also report a lot about the bugs as well. I can help you find bugs. These are similar. These are just the bugs that different people might have found. So, all right. Let me insert a line, because we'll be taking these particular topics of the open telemetry in the next lecture. That is in the live 4 right now. We should take as right. So I found one of the CV in my from Slack. I just know one of them. We'll be taking. We'll try to go through the whole blog that has been written by the project, and that's the Kubescape. If you doesn't know anything about the Kubescape, then it is an open source project that actually looks into your Kubernetes clusters as well as also the workloads. And if it actually tries to monitor different activities and find different vulnerabilities, it usually flags different vulnerabilities that you might have found while working along with your architecture, or while working along with your workload. So it helps you in resisting the chances of your workload from getting stuck by any kind of attack, any cyber attack, whether it is the man in the middle. It's as simple as the man in the middle attack, or either just finding some kind of a bug in the whole cluster failures, cluster policies, or maybe anything else, any kind of the CV that might have flagged in the whole the tool on the basis of which your architecture, your workload might have built, and that might have got some CVs or some kind of bugs that has been improved in the latest version, but you haven't improved them or uh, deployed them onto your architecture yourself. So that's why it's one of the tool, and it's profitable business. Profitable company is the armo. It's been holding managing that particular project. So we'll try to go through that. Fine. Let's find it. Here it is. I hope my audio is all fine. So here's the whole. Here's armo. These are the creators of Kubescape, as I said just now. First real-time behavior, cloud application reaction and response armo. These are different products as well as different updates that they have been launching in their latest releases as features. This particular CV was found on 6th of November this month. It's kind of recent, not as recent, I guess. it's nearly December 25th. 3 new high severity vulnerabilities in Run C. What do you need to know? In 24 hours, 3 new high severity vulnerabilities were disclosed in Run C. NC containers and different container initiative different plugins as well as also components are really helpful in building up your architecture, your workloads, and if any particular kind of CV has been found in those, on the basis of which the whole applications of the softwares are being built, it's a huge issue. So that's why it's really important to flag these issues, flag these particular kind of vulnerabilities that you might have found. Low level runtime that underpins most container platforms, including Docker, Containerity, Kubernetes, and nearly major cloud provider managed Kubernetes services. Vulnerability CV. These particular numbers are being assigned to certain CVs, and if you want to know more, we'll try to go through these particular CVs as well that have been found. We'll try to take a deep dive into each and every particular one then, so that we can get a lot deeper knowledge of how these are being found, how these are really important to be solved, and how they can, what bad effects then can they really cause to your environment or to your workloads at the moment. So yeah, these vulnerabilities allow a malicious container image to break out of the container boundary and affect the host machine directly. The attack requires a specific crafted container. Oh, I guess I should also see if I can share it on my LinkedIn as well. I think I should share it over there as well. I forgot, but I should. The whole thumbnail and all those things keeps up. It's something bad with my internet, I guess. It's fine. It's fine. Let me share it. It's taking too much time. It could be really beneficial if this particular kind of live session would be shared online. If it attract any particular person who does know a lot about the whole landscape as well as a lot about the domain, then they can also help us in finding more bugs or any particular kind of problem that they might have experienced in their organization, or any particular CV that their company or their organization might have found previously. So it's really important. I should have tagged it earlier. That's my problem. I can like let me share it. It will be a lot more beneficial for the whole community, for the whole all the particular people who are present over here. 4 people. Right. So just copy my description as much. So it's dropping already. Right. Right. And I should tag them as well. It's an amazing company. I should. Armo. Yeah. Kubescape. I think it should also have a project. It doesn't have. I think it does have Kubescape. Let me check the spelling. I'm not spelling it. No, it's correct. I think we can take help of Ngrok as well. Oh. Right. So there it is. I'll be sharing this whole Google Docs summary as well in a while, so that any particular person who haven't been a part of this, who didn't had enough luck of experiencing this, of watching this live session, they can go through the whole summary of the documentation at a later time. Right. Do like it as well, so that it can reach out, it can have more reach for the whole community. Right, so now we'll try to go through this particular blog that has been shared by Armo for the Kubescape creators. While the array requires a specific crafted container image, and in some cases elevated privileges inside the container, that is serious. Host comprises or denial of services. That's This disclosure reinforces a recurring truth in cloud security. The container boundary is not a security boundary by itself. Strong supply chain controls and runtime detection are applicable. What is RunC? Yeah, so any person who doesn't know as much about the RunC, then they can get a reference of this particular project from here. I think we should go through RunC live session. That's what it's all about. And see the reference implementation of the Open Container Initiative, OCR runtime specification. It is the component responsible for creating containerized processes, configuration kernel namespaces, C groups, mounts, and process isolations. This enables the creation of containers on Linux machine. Most like EKS or GK on the Linux source you are using RunC. So is the reference implementation of if you might have heard about the Open Container Initiative that has been set up as an open source initiative, for the containerization of the technologies like the Kubernetes and a lot of other things as well. If you might have heard about the Kubernetes, it came out at an earlier time when the AWS was actually made publicly available. Earlier, from the containerization period when it's actually started back in the Docker's time, at that time, a lot of different companies that are really popular. A lot of different popular companies like the alphabet, that is Google, Meta, Microsoft, and right now, like sorry, there was some kind of network issue, I guess, and I was knowing that I will have to refresh the whole live stream in order to get it correct. In order to get me back on the whole live stream. So I'll quickly share my screen right now. I don't think there are as many people at the moment. There have been 4 likes till now. Let's see. Well, we were discussing the CVEs or the common vulnerability exploit that might have found on the internet with the different landscapes or on the cloud or cloud technologies right now. And we were reading a blog. We were reading a blog, a kind of research that have been you know, organized by the armo, who are the creators of Kubescape. This blog is of 6th of November 2025. That is not as old. It's previously uh, written. It's been written previously, and 3 new high severity vulnerabilities in run C. What do you need? Here are the IDs that are provided of these different 3 CVs that have been highlighted in this blog. Let me know if anyone is still live in the chat. Uh, C and Run C is a kind of project that has been implementing. It's into the OCI earlier before my stream stopped. I was explaining that what is Run C and what we mean by the OCI, because it's been implemented by the OCI. So earlier, when the whole orchestration or the whole cloud started, at that moment, the containerization was kind of a popular thing, and so the a lot of containers as well as also the cloud technologies were getting evolved at that moment, and then suddenly AWS dropped its public and private cloud providers as well as the Amazon Web Service or the AWS. Before that, most of these really popular kind of the companies that are the Amazon, Google, and a lot of other stacks were actually using these containerization tech as their internal environments or the tools. At that moment, so Amazon launched its applied public cloud services that can help you in renting their resources. It can help you to lend some of the resources in the form of memory as well as also in the form of the CPUs or GPUs, and a lot of services that can be provided in the form of the consultancies or by the engineers. And in the same way, Google also launched its GCPs. But before GCP was actually being launched, at that moment, Google was also using an internal tool for their for holding or management of their containerization of the containers. At that moment, millions of containers were being used at Google, and all of them were really well managed or really well managed and orchestrated in a way, in a really amazing architecture. And then in that whole architecture or that idea, which was being named at that moment as BOM, was later kind of um, given or provided, or we call it. It was you know it was being given or gifted to the OCI, the Open Container Initiative, which was later being converted into Kubernetes of at the moment of the current time. So at that moment, so this OCI or the Open Container Initiative is runs is the reference implementation of the Open Container Initiative and time specifications. It is a component responsible for creating of the containerization for processes. And it's been responsible for the particular processor, the containerization process, that usually includes the configuring of the kernel namespaces, C groups, mounts, and process isolations. The whole live streaming stoppage broke the whole flow of mine as well. So I'm really sorry for that. If you run Docker, Kubernetes, Containerd, Cryo, or any particular Kubernetes services that are publicly available, like the EKS, or the various different cloud providers, things like the Amazon Web Service or Kubernetes Service, Elastic Kubernetes Service, that has been given by the Microsoft or the GK or the Google Kubernetes engine. So all of these are being managed. If you run them all, any particular stack on your local hosts or your Linux host, then you are using runc at the hood, because it's the particular reference for which the OCR was actually being referenced. Whenever vulnerability affects runc, it affects the foundation of nearly all the containers workloads. That's what I was saying before the whole live streaming got interrupted. That if your application has been built on some of the tools or some of the standards that really matters to the whole architecture, if they got any particular kind of vulnerability attack or any kind of bug has been found in those architecture, then it will affect the whole kind of landscape that has been built around it. If any particular machine has been built on top of that any particular component that's really popular, that's been used widely around the world, then it will affect the whole industry. That's what I'm saying. And that's why these three CVEs are really does matter to us. Let's try to go through each and every particular CVE. After even running going through this particular blog, we'll try to uh, you know go deeper into each and every particular CVE. They have this particular identification number or this serial number that has been given to it, not serial number, but what 2025, and the number, the ID that has been given to the CVE. Vector, a malicious or compromised image. Attack begins with a malicious container image, either crafted intentionally by attacker does not mean to exploit a kernel bug. Instead, they exploit how runc handles mounts and special files during containers start like a mining, symlinks, bind mounts, and some tuning tricks. The attacker convinces runc to write to the host's proc file system, the processing that has been running. External rock and external rock, we have discussed them as well in the K-gateways documentations. Yeah, there will, if you ever know more about the gateways or the gateway APIs in while running your workloads or the environments, then you can go through the first live session prior ran through the K-gateways docs proc file systems instead of container views of it. This is where the real danger begins. Let's go through it once again. Attacker does not need to exploit a kernel bug. Instead, they exploit how runc handle mounts and special files using container startup. By combining some links, bind mounts, and some tuning tricks, the attacker convincing runc to write to the host's proc file system. Right. An attacker can achieve proc is a virtual file system used by Linux to expose and control kernel behavior. Oh, right. Virtual file system used by Linux to expose and control kernel behavior. Containers should see their own copy of proc separate from the host. Right? If a malicious container can write a specific proc file of the host, it can. Oh, so they have. I think they have attacked a particular container. The attacker have exploited or runc handles. I think they are exploited by the container. That's the whole reason of how the CVEs really matters. So the virtual file used by the Linux to expose and control the container. Yeah, that we have read. Container should see their own copy of proc separate from the host. A malicious container can write to specific proc files or the host. It can kernel code and arbitrary commands the host whenever any process crashes. That's a huge issue. System trigger forces a system reboot or crash immediately or denial of service. Settings modify kernel level system behavior, potentially weakening security. Or these particular this CV really matters a lot to any particular container that is running, any particular architecture that you're running along with runc. So, proc file is a virtual file system. Who doesn't know? That has been used by the Linux to expose and control the kernel behavior. Container should see their own, copy of proc file system separate from the host. Each and every particular containers, if you will go into the terminal of every container, you'll be able to see the copy of each and every particular proc file of their separate containers that have been running. There might be multiple containers that are running on the host, so that's why it's saying that the copy of proc file might have been stored and you can view it on each and every particular container. If anyone, a malicious container can write to the specific proc file of the host, right, it can do these uh, harm to the whole architecture of the whole workload. We write them down as well. This does matter a lot. In practical terms, the attacker could gain execution on the host, cause a full cluster outage, maintain the persistent beyond container lifecycle. This container escape achieved without touching the kernel or hypervisor. The attacker is simply using the run cease trust that the container file system is isolated, which under the IR conditions is not. Alright, so this is the major problem that users faced a lot at that moment. I think we should run through and write them down as well on our doc file so that you can later go through the whole summary of this particular live, or either you can just go through the summary docs and just get to know what did we discussed or what we found new. Right. Let's specify the names and the IDs as well of Runcy. CVEs. I will just write simply whatever is being mentioned. It might not look as good as a professional one. All right. I want to write this. All right. Let's see. No, it's Runcy. Just yeah. Oh, I'm not using it now. And we also specify what is this Runcy project for any particular person who doesn't know as much about the whole project. Then it could be kind of a confusing thing. They can get confused if they doesn't know about the project itself. So maybe put specific uh, definition that has been mentioned over here as well. It might not be as much of kind of a copyright or anything else. So that's why I'll be mentioning the same thing. Yeah, that's the general, or I might take it from the Google itself. It might be a lot better, or from the Runcy. Let's take it from the official documentation itself of Runcy. I'm gonna write anything else. Reference. Well, Right. So I'm taking it from the official documentation, from the official, logs of the documentation that has been mentioned on the Docker, as well as also on publicly available on the Google. That's what I will be writing it. Yeah, currency. All right. Let's underline as well and bold. Make it bold. Not R proc, but proc files, processing files. We'll try to mention some of the ways in which it might have exploited their systems. And let me close my door first of all. It doesn't look as good, so that's why I just closed it. Otherwise, it switching to right now. My voice must have been a lot better, I guess. How many views are present? 6 of them. Good. Right. So let's see. I guess I should just write each one of them instead of just copying the whole table. It will be a lot better, to be honest. Right, and for system reboot as well. Right. Yep. All right. So This one of them, this one has been taken. I should give reference to armo, creator of Kubescape. We shout out to armo as well as also to the Kubescape project. If you don't know as much about these, do check it out, and let me place its link as well in my docs. Yeah. All right, so let's hop back to our recent documentation or the blog documentation. Just specifying about these particular CVEs that we have found. In practical terms, the attacker could gain execution on the host, run RPD commands that's in simpler words, cause the full cluster outage, reboot or crash, maintain persistent beyond container lifecycle. Modify container level system behavior, potentially weakening the security. This is a container escape achieved without touching the kernel or hypervisor. The attacker is simply abusing runs trust that the container file system is isolated, which under these conditions is not. Mesh is compromised container image, then the container engine would be compromised, and then later run C, mount side of a namespace preparation, file system isolation expected. Has been extracted, but it's been exploited. That's why symlink bind mount manipulation writes to the host proc instead of just container proc files. Host impacts are these particular points that has been mentioned above as well. Modify container behavior, trigger system crash, execute code privilege, and container escape and host compromise. How to mitigate and what cloud users need to know. You manage your own Kubernetes nodes, then update the runc to the highest version. Obviously, if you find any particular kind of the CV, then you just have to flag that particular CV to the project owner or to the community that's been holding it or been organizing that particular project. And if they see it, they'll probably they will start working on it most probably, and get it improved in the as soon as possible, so that the whole impact could be reduced. Impact radius could be reduced, or your distributions equivalent. Example from the Docker or the container releases. Yeah, either that particular there you does have different approaches to find a solution to any particular CV at the moment. If you does find any particular problem, let's say in the run C, then you can flag that particular kind of CV or that particular kind of bug to the community itself, or either to the different engines that you are running at the moment, whether it is Docker or either you are using AWS or any other cloud provider, or the services you are using at the moment on which runs your that particular project has been hosted. You can just kind of flag it, that particular kind of problem to them, and then they can start working on it. If the project owners won't start, then they'll at least start, because any particular component that has been attached, that has been integrated, and which is as big as runc, it can surely affect AWS and a lot of other cloud providers as well. And that's why you've been seeing a lot of cloud outage, as well as also the data servers have been crashing a lot. On Diwali, I think AWS East, US East one, that particular server, the branch actually got crashed. So yeah, a lot of memes were running on the whole LinkedIn. That's the Diwali of cloud servers, but not in a good way. So yeah, if you manage Kubernetes, EKS, AKS, or GKE, check AWS security bulletin. It is AWS AKS node base image will be best. User must re-image or rotate nodes. See security bulletins over here. Look for security releases. Google GKE, Google Kubernetes Engine. Look for security release channels and perform node pool upgrades. In all managed Kubernetes cases, upgrading the control plane is not enough. Worker nodes must be refreshed as well. So control planes does hold some of the control plane actually acts as the brain of your whole cluster of your whole workloads. So it will be managing a lot of different things such as the HCD or the kubelet or API server and a lot of things, other things as well. But the worker nodes will be taking care of different other parts that will be assigned or being managed or being supervised by the control plane and will be doing the real work that has been kind of ordered or been asked to do by the control plane itself. So that's the work of working nodes. So any particular kind of CV that we might have found, it won't be enough to just upgrade the control planes. You'll have to refresh your worker nodes as well. Improving overall security posture. This even highlights a long-standing security reality. If a container is running our untrusted code, assume it can escape under the right conditions to reduce the exposure. Don't run untrusted or unsigned container images. Yeah, so these are some of the precautions that can be used as these can be considered as the best practices by any particular cloud engineer, any particular admin that's been responsible for integrating a lot of different solutions into their workload. So these three things are some of the most basic ones. Don't run the unsigned container images. That's one of the most basic one. Untrusted unsigned container image. Implement runtime threat detection. That's also one of them. Runtime threat detection. Even the patches and signing, supply chain compromise is always possible. 0 day in base image, compromise build step or malicious dependency. Employ zero trust workload identity type behavior to workloads, not IPs or nodes. All right. Yeah, so you should tie behaviors to the workloads instead of just assigning or by tying along with the IPs or nodes. You should tie certain triggers that should be performed under certain conditions. Zero trust kind of workloads for to your whole workloads, not only to the IPs or nodes, because in such kind of CVs or in such kind of exploits, you might see a lot of pods or nodes being going down. You might see they are getting auto deleted or might getting exploited or might get they might end up getting deleted. So that's why it won't be a really nice thing to tie behaviors to the certain IPs or the nodes, because you might try switching them in case of any particular kind of an attack by the any particular kind of cyber attack by any particular malicious activity. So you should bind them to the whole workloads and in a certain way so that they can reflect the whole security of your entire workloads. Fancy vulnerabilities are not just another set of CVEs; they are a reminder that the containerizations does not equal security. The isolation boundary is thin, and attackers are creative. To stay secure, path run, rotate your Kubernetes nodes, avoid untrusted images, and most like monitor what workloads actually do at run time. Yeah. With Armo, organization gain continuous detection. All right. We shout out to Armo as well as to the Kubescape and to the Ben Hirschberg. I guess I must pronounce it. CEO and co-founder of Armo. Great. Uh, how many people are viewing it? Quite a lot. For me, at least. 6 of them. Oh, seven. That's good. Hey, everyone, thanks a lot. I'm not ending it at the moment, but thanks for uh, coming back to the live session. Right, so now let's see some of the series as well. We might find some. No, let's try to view on over here. Can I share my screen on? Let me share Windows. Yeah, over here. Let me share. Here is one of the Slack channel. You might found a lot of chat, a lot of CV alerts, and a lot of other things as well. And the whole thing is impossible. Like, no problem. Let me share this instead. I was show. Yeah. Let's write some more things. Some things that have to be performed in order to say your architecture, your whole workloads, not architecture, or myself. Right. So to stay secure, just precautions. I should make in the form of a doctor. So don't trust, untrusted or unsigned repositories or images. Keep monitoring the behavior of your workloads. And what else? Implement threat detection and better alert management as well. Rural communities nodes as well, yeah. Get your these nodes, just upgrading your control plane won't be enough. Might need to restart your worker nodes as well. Right. Let's see if we can find some other CVEs as well. A particular thing that might have been detected. And then try reversing the new CVEs and let's see. Just wait for a second. I might have to go. Just right. So change of plans. We are continuing our lives, our whole life from this background. I guess there's some kind of problems, some kind of issues. So that's why we'll be continuing them. I guess. I don't know which one is that. Let me try the IDs as well. That's better. Right. So All right, two people, four people. That's great. Thanks. Right. Just give me 1 minute. Right. Hey, Devesh Chauhan. Right. 8 people. That's a lot. Thanks a lot for joining my stream. We got interrupted 2 times. Right. So let's get started again. Let's see what else is possible. What other CVs are being found at the moment? We'll try to look at them. Till then, instead of just viewing my face, you can just uh, let me share my screen so that you can just get a quick grab for the whole summary of the stream till now. As we try to find some of these CVEs, there's the CV whatever number or ID that has been given. We try to check them from the one of the blog that was mentioning, explaining about these particular CVEs from the armo, who are the creators of Kubescape. Uh, these three CVEs were found in Run C. And see, there is the reference implementation. There is a lightweight portable container in time. It includes all the plumbing code used by Docker to interact along with the system failures or features, not failures, along with the system features related to the containers. It's if you're using Kubernetes, Docker, if you're using Containerd, some of the really important tools, softwares, or uh, particular frameworks that is being based or being highly used over there at the cloud, then run C is the one who's been running under the hood. And if that particular kind of software, that kind of tool, if got you know if that particular kind of a tool got some kind of vulnerabilities, if that kind of a tool got attacked by some malicious uh, bugs, yeah, some particular bugs that might have found in the whole architecture of that application, then it might get really dirty. To be honest, it might get really bad in the long run for a lot of different applications and systems that are running this particular process under the hood of each and every particular containerization tools or the whole systems and networking applications. If you are even using GK or AWS, AKS, or some of the tools as well, then it might be really bad. No screen. Oh, am I not visible? Am I visible right now? There is Sean. There are 9 people. That's not great. Can someone? All right. I does have opened my own live. Let me check. I'm connecting my Bluetooth system. Right, so I am live and I think I'm audible. Yes, I am audible. Great. So we'll keep discussing about some of the CVs as well. Yeah, it's the same CV right now till now. The zero CV image. Yeah, that was kind of the precautions that has to be kept that are to be kept in mind by any particular administrator or even a cloud engineer in order to save their workloads from any such kind of malicious attack from any particular uh, process that might have failed into their own application, or any particular bug that might have found by the attacker and can be used in order to access the the kernel and play around with the whole working of kernel as well. 13 people. All right, right. Okay, so let's try to look at some of the uh, issues as well, some of the CVs as well. Let's see if any particular CV is being reported on the whole official documentation of CNCF itself. Um, session is being based so that we can find some of the CVs that are available at the moment in the whole landscape. Uh, there's some kind of network issue, I guess. Right. So this particular live session has been organized in order to find some of the CVs and to discuss them and learn about different CVs that we might have found or different developers or organizations might have found previously. Like one of them was this, which was based on the Run C. Run C has been run under the hood for most of the applications, most of the containerization applications, and over the clouds if you're using Containerd or some of the cloud providers services as well. If you're using AWS or GKE or anything, any other particular cloud services either, you'll be running Run C under the hood. So that's why it becomes a really important kind of a CV, because it can it does hold a huge uh, impact radius, because a lot of people are using it, so its impact radius would be huge. Servers also have been going down recently. One of them was the Cloudflare. Before that, Cloudflare does have some kind of bugs in its own code base, so that's why it gone down. Other than that, and some other features as well, as soon as it got pushed, then the things started breaking down. So that's why it got that much of a huge impact radius. And then that some other things as some other clouds also broke down recently on Diwali. AWS US East 1, I guess it crashed, that server, his whole server. That's why it also created a lot of mess in the whole cloud systems. And after that, between both of these events, Microsoft Azure also had similar kind of server crash. So there's been a lot, and it's all because the whole cloud architecture and infrastructure haven't been produced so well, so maintained as well. When the whole information, whole technology are getting improved each day, it becomes really important for them as well to keep up the whole um, thing up and running and updated as well. Let me see if we have some other issues as well. I guess I have answered the whole question. If you guys have any other particular kind of doubt, then I might be helpful in solving them as well. Let me see some other CVs as well that we might have found over the whole landscape, I guess. Security. Do they have tag security? Security events? No. Right. Devish Chauhan. By the way, where are all of you guys from? It's 10 people have joined till now, uh, so it's quite a big number for me. Otherwise, it would have been 4 or 5, I guess. MP Jabalpur. That's great. All right. So here's the whole tag group of security, that is of CNCF. CNCF does hold a huge landscapes and which holds a lot of different projects as well. So it will be having a lot of different projects. It will be having a lot of different flags of different CV would be flagged over in this particular um, community as well. You might join it. Catalog governance projects, organic governance, catalog of supply chain comprises, right? I think there must be some kind of community conversation where we might find some kind of previously found. Let me check. Let me share it instead, I guess. It's great. I'm from Jodhpur, Rajasthan. Um, why isn't it visible? I guess it is. Right. Right. Let's find some other channels as well that might be present. Browse all the channels. Let's see if it does have some other channel as well for security. Tag security events, controls. If does know the recent, CVs that might have been found, I would love to uh, review them as well. Or either we can go through these previous ones within the. I think NG-Rock also holds some kind of CV blogs. So, yeah, let me check my. It's kind of slow. No, it's fine. What happened to my laptop? I don't know. There must have been some kind of problem with the hotspot. It's, that's fine. Cool from VMware, free type, and Kubernetes. Let's try to look at it. US CVs tenable. Hmm. Oracle does have some recent CVEs, Oracle database, communication unified, inventory management. They have projects. They does include, they bind a lot of different, the whole stacks. So that might not be as great. So it's a great project. Let's look at it either. Kind of recent, yes. Just let's look at, I guess, Kubernetes. Let's look at the Kubernetes official repo. Might have some kind of security issues that might be open at the moment or might have been closed earlier. Is it solved now? Vic? The whole buffering and lagging of my, it might be, the camera is not stable at the moment. I've been sitting on the bed. I'm not sitting on my desk at the moment. It's there's some work that's been going on in my room at the moment, so that's why I've just set up my whole uh, on my bed. So you might have been confused. It does hold a lot of conversations, so it might be helpful for us as well to go through the whole thing. Let's see the sign and all. Let's how old is it? 5th of August, and that's thanks for the update. Vision board. Recently, while testing the performance of VPA multi-instance scenarios, I observed an issue. As the number of VAP or admission policy binding increases, the latency of the API authentication resources continue to rise. The CPU usage of API server grows significantly. Binding numbers, parameters numbers, and delays average CPU usage QPS. Alright. Test environment is 4 core, 8 GB cloud server, and the kind cluster is configured as below. It's being configured on cluster. Uh, API version is using kind. It's using kind cluster, I guess, and defining roles within the control plane. Image, extra port mapping, container port, host port, and protocol has been set. Creating config patches, kind, API server, extra arguments. Opening has been set to true. Okay. Role is worker image. It's using different image. Alright, so different nodes have been configured. The control plane, and control plane is holding the whole definition. The extra port mapping, host protocols, TCP, which kind of protocol have to be used in that particular use case. The worker node just have the whole image. Now, bringing the level of performance is inefficient for certain large production environments. Excessively high CPU usage can cause the API server to become unresponsive or even crash and restart, while high latency further impacts the API server's ability to serve. By analyzing the ROF results, account performance bottleneck is the request value error. Oh, let's have a look over this particular file as well. That's kind of fun. So, why should we move on it as well? Staging source Kubernetes. Nice. Yeah, staging. Was the whole? Let me write it. Just copy it and have a look. Yeah. Kubernetes staging sources Kubernetes.io API server. It's the file for the API server package and we can plug in CL based authentication and all that. So it's the Go file, going file that has been written. Let's review it, go through each and every particular line. Package CL because it's using it, and import context FMT, GitHub, Google, CL, Go interpreter, math, time, admission VI, Kubernetes.io, API, admission VI, V1. Alright, Kubernetes.io, API code V1. Women's, alright, yeah, that's great. It's a great idea to just go through the whole Golang file as well that has been written for each and particular different components that we are using in our day-to-day life. For the V1, it's been referencing the V1 in this format, Kubernetes.io API code V1 and admission CAL library. Hello, hey Aditya. Activation, composition context, composition CTX, context, version, attribute. Alright. It's been using this particular function to define the whole objective. What which particular line was it flagging that it does hold an error? All right, our whole function has been therefore has new activation function. So the investigation, the call chain of the function, I found that the root cause of the performance degradation in loop within the whole function. C dispatch, right? Let's see. Function C. I can't find it. Can't find it. Where it is? Dispatch. Function dispatch. Let's resolve names, and this one is the one who's calling each and every particular function in the whole cycle. Right, it does not have a function with that name. Specifically, the performance bottlenecks times iterative processing of web binding objects and policy parameters inside the method. As the number of web binding instances increases, the loop's execution time grows significantly, leading to higher latencies and increased CPU consumptions. To concisely describe the issue, I have omitted irrelevant code and include only the core portion directly related to the problem. Let's find it. I think it's referencing some other document. I want to share this same tab because it's not talking about the same policies and all. Just referenced it over here, and then other than that, it's not now. It's maybe referencing some other document, some other file that is stored in the whole project repository. Through investigating the call chain of the function, I found that the root cause of performance degradation actually lies in the loop in the following functions of over here. It's using C dispatch. It's been um, using context, not context. Admission dot attributes or admission specifically the performance bottleneck stems from iterative processing of web binding objects. Performance bottleneck stems from the iterative processing of web binding objects. Alright. And policy parameter inside this method. Let me see one more thing. Alright, so I was a bit confused over web binding as well. What is this web binding? Yeah, it's correct. It's the validating admission policy binding. It's the core concept introduced under the validating admission policies. Yeah, web. It's kind of an API reference, the resource API resource that's been used to ensure or enforce the policy rules that's been defined by a web on specific resource within a Kubernetes cluster, any particular workloads cluster in your whole environment. Perform borderline stems from the iterative processing of web binding objects and policy parameters inside the method. As the number of web binding instances increase, as the policy enforce resources the iterators increases, the loop's execution time grows significantly, obviously, yeah, leading to a high latency and increased CPU consumptions. Correct. To concisely describe the issue, I've omitted irrelevant code and included only the core directly related to the problems. For binding, range hook bindings, node generic core parameters. You might have to go through these particular lines as well. From the code, we can observe that every particular incoming request, the API server iterates through all the VP binding associated with the policy, retrieving the corresponding parameters via each binding, and then performs the admission checks. With the iterations, third request by analyzing the source outer loop over the binding inner loop over parameters as well. It does understand as well, but for understanding the whole file and these the different classes, the values that it's been referencing to, might have to take a look over the file as well that he's been trying to edit for now. Dispatcher dispatch function loop over each validating. Alright, let's see if there's any. Alright, so it's it's the same file activation.go. Yes, right. Yeah, activation.go. It's the same file. I guess he wrote some extra code instead of omitting them. All right, we're back. Let's see how quickly we can gain those views again. Kubernetes staging source. All right, now yeah, this one.